Hi. I'm Griff, a guy with no degree, attempting to explain quantum particle physics. In this series I'll be pretending to understand some of the most perplexing mysteries of the universe, in an effort to create something informative and entertaining, so hopefully, by the end of the video, you can pretend you know what the you're talking about too. Physics, especially quantum physics, is a callous cluster of calculations, conundrums and cosmic conclusions that even confuse the most curious cousin-cuddling patent clerks. There are many great unknowns, including, why is light a swing voter? Why is gravity such an outcast? And, how can two entangled particles know what each other are doing, even from the other side of the universe? Concepts that are hard for an intelligent, rational person to get their head around. Fortunately, that's not what you're dealing with here. So, what is quantum entanglement? First, it helps to get a better idea of what spacetime actually is. It's basically just space, so why does time always get involved? Well, it's actually pretty simple. Space is made of 3 dimensions. Up and down, left to right, and forward to back. But Einstein's special theory of relativity explains that a 4th dimension is required to describe any position in space. You can give someone the coordinates of an object, but that doesn't do them much good if they don't know when it will be there.
The question isn't what they want from us, Constable, but when.
You can have an appointment on the 3rd floor of the building on the corner of 4th Street and 9th Avenue, but even though you know exactly where to be, you can still miss that appointment because you don't know what time to be there. See, you can't talk about space without talking about time, and vice versa. If you move through space, it takes time, and you can't experience the flow of time without taking up space. Imagine you built a time machine. You get in, press the button and poof, you're off to visit your younger self. Unfortunately, when you get to the desired time, you find yourself floating in the vacuum of space, freezing cold, and quickly dying. In your final moments, you realize that you forgot to consider the movement of the Earth through space over time. Fortunately, you always keep a jetpack and spacesuit with you for emergencies. Who doesn't? You equip yourself and head in the direction of Earth, but your jetpack only propels you at a slightly higher speed than Earth is moving away from you. By the time you get there, it's basically the same time you left in the time machine. Since you age in the time it takes you to get there, technically, you did travel through time to visit your younger self, just in the opposite direction that you expected. Isn't this fun? I wonder. Since we can build machines that travel through space, but, due to speed limitations, are confined to a given amount of time. If we could build time machines, would they be limited by size, to a given space? Anyway, as you can see, it's just easier, and more helpful, to talk about space and time equivalently, considering time as just another dimension of space. Therefore, hi. Me again. Just wanted to remind you that this is only one installment of a multi-part series. There's much more to be said about dimensions, particles and light. But in order to get these out in a timely manner, I'm working alone, on a tablet, in my spare time. I had to split it up into chapters. Be sure to subscribe and click the notification bell, so you don't miss out on each new episode, as they come out. Thanks for watching. See you all again soon.